Hi everyone, I welcome back you all to my next video. As you all know, I am Chitrashriyam. My USN is 1VE23CS042. Currently pursuing my BE in Sri Venkateswara College of Engineering in the Department of Computer Science and Engineering from second semester. In this presentation, I will be discussing about the subject Computer Aided Engineering Drawing, which has the subject code BCDEK203 related to the topic Introduction to CAD. Let's know the brief contents of my presentation. Initially, the introduction, drawing instruments required, types of lines, quadrant systems, and two problems. One is related to the projection of points and the other is related to the projection of planes. Let us start with the introduction. Engineering drawing is a handy tool of communication used by the people associated with the design, manufacture, and use of any product of technology. Examples like automobiles, airplanes, building structures, bridges, ships, machines, and etc. Engineering drawing is two-dimensional graphical representation of the various 3D physical components used in the product. Engineering drawing contains all the requisite information related to the components such as true geometrical shape and size, material of construction, sequence of processing or machining, sequence of assemble, and procedure for usage, and etc. There are some drawing instruments which are specially required for manual drawing in engineering drawing. They are 30° 60° set squares, 45° set squares, protractor either circular or semicircular, compass and divider, pencils of different grades like H grade and HP, pocket knife or blade, sandpaper, eraser, French curves, rota scale, sketchbooks and microtip pencil. We should have some knowledge about the usage of different types of lines in computer drawing, like thick line, continuous thin wavy line, continuous thin with zigzag, short dashes of different gaps and different lengths, long chain which is thick at end and thin elsewhere. Yes, we are familiar with the quadrant systems. Especially in two-dimensional figures, we refer two axes. One is x-axis and the other is y-axis. If any particle or the object lie in between the angle of 0 to 90°, then it will lies in first quadrant. If it is lies in between 90 to 180°, then the object is present in second quadrant. If the angle is in between 180 to 270, then it will lies in third quadrant. If the angle is lies in between 270 to 360, then it will lies in fourth quadrant. When it comes to the projection of points, we have to assume one reference line and we should name it as x and y. It has two planes, one is the horizontal plane and the other is the vertical plane. If the given question contains the point lies above horizontal plane and in front of vertical plane, then it will lies in first quadrant. If the question contains above horizontal plane and behind vertical plane, then the object lies in second quadrant. Below horizontal plane, behind vertical plane, then it is the condition for third quadrant. At last, if the object present below horizontal plane and in front of vertical plane, it is the condition for fourth quadrant. We have to remember that always this vertical plane is stationary and this horizontal plane always used to move at an angle of 90° in clockwise direction. Initially, the observer in all the four quadrants is assumed to be stationary. Before that, we have to know one small condition, that is the top views of either lines, points or planes is represented by small letter A dash, B dash and C dash, whereas the front views are represented by small letter A, B and C. Point A in first quadrant. We know the condition for first quadrant, that is the point lies above HP, that is above horizontal plane and in front of vertical plane. When this point is observed from the top view of a point initially lies on horizontal plane. When it is observed from the front view of a point lies on vertical plane. We know that the vertical plane is always stationary and this horizontal plane is movable, so that the top views on which the point lies on the horizontal plane, it is rotated at an angle of 90°, so in clockwise direction. So finally the top view of a point A lies below the xy line, whereas the front view of a point A lies on above the xy line. When it comes to the second quadrant, we know the condition for second quadrant, the point lies above horizontal plane and behind vertical plane. When it is observed from the front view of a point lies on vertical plane. Initially, when it is observed from the top view lies on horizontal plane. Then it is rotated at an angle of 90 degree so that finally both front views and top views of point A in second quadrant lies above the XY line. When it comes to the point in third quadrant, we know the condition for third quadrant. The point lies below horizontal plane and behind vertical plane. Initially, when it is observed, the top view of a line lies on horizontal plane and the front view lies on vertical plane. We know that the vertical plane is stationary, so that the top views on which the point lies on the horizontal plane, it is rotated at an angle of 90 degree. Finally, the top view lies above XY line and the front view lies below the XY line. When it comes to the fourth quadrant, it is opposite to the second quadrant. Initially, so we know the condition for fourth quadrant. The condition is the point lies in front of vertical plane and below horizontal plane. When it is observed from the top views initially lies on horizontal plane. When it is observed from the front view lies on vertical plane. So the horizontal plane is rotated at an angle of 90 degree. Finally, both the front views and top views of point in fourth quadrant lies below the XY line. Before moving into computer drawing, we had to know some key points. That is, HP is nothing but horizontal plane, VP is nothing but vertical plane, PP is nothing but profile plane, either LPP, left profile plane, or RPP, right profile plane. The thickness of XY line is 0.35 mm. The thickness of thick line is 0.50 mm. Thickness of thin line and as well as the projection line is 0.13 mm. The thickness of point is 2 mm. As I selected one problem from projection of planes related to the pentagon, we had to know the inside angle of pentagon, that is 108 degree. But here in computer drawing, we are considering the outer angle, that is 72 degree. And some representations like front views, small letter A dash, B dash, C dash, top views, small letter A, B, C, side views, A double dash, B double dash, C double dash, and D double dash. There are many softwares and tools available for computer drawing, but here I am using Solid Edge V19. The given first question is related to the projection of points. A point P is 25 mm above HP and 20 mm in front of VP. Another point S is on HP and 30 mm behind VP. The distance between their projectors measured parallel to the line of intersection of VP and HP is 50 mm. Find the distance between the top views of point P and S. Initially select the line option. I am drawing XY line, so it should be of thickness 0.35 mm. Let me draw one XY line. Select the text option. Name it as X and Y. They have given point P is 25 mm above HP and 20 mm in front of VP. Above HP and in front of VP, it is a condition for first quadrant. In first quadrant, the front view of a line lies above XY line and the top view lies below the XY line. Select the line option of thickness 0.13 mm, of length 25 mm, and the angle is plus 90 degree. Place it on XY line. Move to smart dimension, measure its distance, and it should be of 25 mm. Select the point option of thickness 2 mm. Select the text option. It is the front view of point P. It is represented by small letter P dash. Small. Again, select the line option of thickness 0.13 mm, of length 20 mm, and the angle is minus 90 degree. Move to smart dimension, measure its distance. It should be of 20 mm. Select the point option of thickness 2 mm. Place it in the corner. Select the text option. It is the top view of point P. It is represented by small letter P, top view. Before moving into point S, they have given one condition, that is the distance between their projectors measured parallel to the line of intersection of VP and HP is 50 mm. It means the distance between the projector P and projector S is 50 mm. Select the line option. Select the thin line of thickness 0.13 mm, of length 50 mm, and the angle is 0 degree. Place it on the XY line. Move to smart dimension. Measure its distance. It should be of 50 mm. Again, point S is on HP and 30 mm behind VP. Point S front view lies on the XY line and its top view lies above the XY line. Select the line option of thickness 0.13 mm, of length 30 mm and the angle is 90 degree. Place it after 50 mm line. Move to smart dimension. Measure its distance. It should be of 30 mm. Select the point option of thickness 2 mm. Place it in the corner. Select the text option. It is the top view, small letter S. Front view S dash. Point S. They have asked us to find the distance between the top views of point P and S. Select the line option. Select the thin line of 0.13 mm. Join from the top view of first projector to the top view of next second projector. Go to smart dimension. Select the line and measure its distance. So finally the distance between the top view of point P and S is 70.71 mm. Is related to the projection of planes, especially related to the pentagon. A pentagon level of edges 25 mm is resting on its peak with one of its sides such that the surface makes an angle of 60 degree with HP and the edge on which it rests is inclined at 45 degree to VP. Draw the projections. Initially select the line option of thickness 0.35 mm. As I am drawing the XY line, let me draw one XY line. Select the text option. Name it as X and Y. Usually in projection of planes, the first quadrant is considered. So above the XY line, vertical plane. Yes, the second question is related to the projection of planes, especially related to pentagon. A pentagon lamina of edges 25 mm is resting on HP with one of its sides such that the surface makes an angle of 60 degree with HP. The edge on which it rests is inclined at 45 degree to VP. Draw the projections. Initially, let me draw one XY line. It should be of thickness 0.35 mm. Let me name it as X and Y. Usually the projection of planes is considered in first quadrant. So in first quadrant, the vertical plane lies above the XY line, whereas the horizontal planes lies below the XY line. Let me draw one pentagon of length 25 mm, of thickness 0.50 mm, of length 25 and the initial angle is 0 degree and the length is 25 and the outer angle of the pentagon is 72. Length 25 and the angle is 72 into 2. Length 25 and the angle is 72 into 3, 25 and 72 into 4. Yes, let me select the whole pentagon. The given condition is a pentagon lamina of edges 25 mm is resting on HP. HP means it will lie below the XY line with one of its sides. They have said that the side is resting. It means it is the edge condition. Select the entire pentagon and select the rotate option. Select entire one of its entire edge and rotate it. Move to smart dimension, measure any one of its sides. It should be of 25 mm. And select the text option and name all the corners. Corner A, B, and E. Select the line of thickness 0.13 mm. Extend all the corners. up to touching a XY line. Select the leader and show the arrow mark. As they all are moving upward, show the upward direction. Move to line option and select the line of thickness 0.50 mm. Join all the three corners. Select the text option. When it is observed from the bottom, point B is visible, A is not visible. Here point C is visible, whereas point E is not visible. And finally, the point D. Move to select option and select this front view and as well as the line. Move to move option. Say, make sure that the copy option is turned on. Select any one of its corner and move and place it on XY line. Again select both the lines. Move to rotate option. Select both the corners. They have said that with respect to HP, it is inclined at an angle of 60 degrees. So the rotational angle is 60 degrees. Move to angle between and measure the angle between these two lines and it should be of 60 degrees. Select the line option. Before that, select the text option. This is B dash, A dash, C dash of B dash, and this is D dash. Move to line option. Select the line of thickness 0.13 mm. Extend all these lines towards downward direction. B dash line is extending. It should be extended up to the point B. And here C dash of E dash is extending. It should be extended. It should be extended up to the point C. And D dash is extending up to point D. Show the leader. As they are moving downward, show the downward arrow mark. Again select the line option of thickness 0.13 mm. Extend all these points in horizontal direction. Point A is extended up to touches the line A dash. First let me extend point E. Point A. D dash at one corner. Point C and C dash meeting at this corner. Point D and D dash. Select the text option. This is the point where point A and A dash are meeting. Let me name it as small letter A. And this is the point B. This is C. This is the corner D. And this is the final focal point E. Join all these points using the line of thick line of thickness 0.50 mm. First, place it on point A to B, B corner to C corner, C to D, D to E corner, and E to A. Let me delete this unwanted line. Yes, the next condition is the edge on which it rests is inclined at 45 degree to VP. Select one line of thickness 0.13 of angle minus 45 as we need in below the XY line, so it is selected as minus 45. Go to angle between and measure its angle. It should be of 45. Yes. The edge on which it rests is inclined at 45 degree to VP. This AB edge should be placed on the line 45 degree line. So let me select this entire pentagon. I will select the move option and make sure that this copy option is in on. Let me select one of its corner and let me place it on XY line, 45 degree line. Yes, the pentagon is selected. Again, move to rotate option. Select two of its sides or edges and make sure that it will place on 45 degree line. Yes. Move to text option and name it as A corner, B, B and E. Again move to line option and select the line of thickness 0.13 mm and extend all these lines. Point A is extended up to touches the A dash as A dash and B dash both are lying on XY line. Point A and B both are extended up to touches XY line. A is also extended up to XY line and now B is also extended up to XY line. And point C is extended up to touches C point. Here the C dash point is here, so it is extended up to touches C dash. Point D is extended up to touches D dash. And finally the point E is also extended up to touches E dash. Go to text option. This is the point where both A and A dash are coinciding. So name it as A dash. And here the point B. And the point C is somewhere here. The point D is here. And this is point E. Join all the corners using a thick line of thickness 0.50 mm. Yes, 0.50 mm. First point A to B, B to C, C to D, D to E, and again E corner to A corner. This makes the complete computer drawing. Thank you for watching my video.